Hey, today we're going to be unboxing this pH controller, Amazon. It was fairly inexpensive. It was $79 and it's Canadian dollars, sorry. And it's pretty much remained that way for quite some time since it was, since about September. It's been as high as $105 just so you know what you're looking for so you don't overpay for it. Comes with some suction cups to attach the pH controller to whatever you're using it on. A little plastic screwdriver to adjust it. pH buffer solution for calibrating. And the rest of it just kind of fold over the box. So all the cardboard's kind of stapled together. So that's the fastest way to get it out. It's also a little ambiguous because on the ad on Amazon, it shows a European style plug with the universal for controlling your solenoid there, right? So pretty much as expected. And comes with one of these slightly more inexpensive pH probes, but at least they leave it sitting in a solution so you don't have to worry about the rehydration period where it won't be reading very accurately and drifting like crazy. Okay, the user relay, you can hear it click as soon as you turn it on, so that's a little unfortunate. Long term, that isn't going to be as reliable as a solid state controller made using a thyristor or something of the sort. So let's just hook this up and calibrate it. Also, they list glass, but this definitely feels plastic. Okay, first of all, the manual is just kind of unfortunate. It doesn't work. Doesn't really have very good instructions on how to calibrate this thing. So first, what I would do, you take it out of the calibration solution. I like to rinse in some RODI water. Set it in there for a minute. Now we want to set it to pH. We want to take the top off the pH solution. Get to drip as much water off the probe as possible. Submerge it in your buffer solution. Make sure not to stick it in all the way or the solution's going to overflow. Now we have to just let it sit here for a minute while it stabilizes. So you can see it's still changing. Okay, after waiting about 5 minutes, you can see that the pH is still reading, still not quite up to the pH of 7. So most of your buffer solutions will come with a little calibration range on the bottle telling you what the pH is specifically at any given temperature. So now you just need to adjust the calibration right here. Just put a little screwdriver in and adjust it until well, a little bit more finicky than I expected it to be, but my calibration solution says it should be at 7.02 at 20 degrees Celsius. It's about 20 degrees in my room right now, so that's pretty much as close as it's gonna get. It's kind of hard to show how finicky that is, but I barely touch it and it's changing significantly. So now I will rinse this off, take it out of the pH solution, the buffer solution, and rinse it off in some RO water. Stick it back into its little storage vessel because you want to keep the head submerged and wet at all times. You don't want to let it dry out. Seal this up. Now most people like to keep their calcium reactors between a pH of 6.1 and as high as 6.8. So for now, I'm going to set mine to go at 6.5, just happy medium, and see how it works with my media. Okay, you've flipped over to set, adjust your set point. So now it'll regulate to that pH, and then you flip it back to pH. And you can see that the solution that's being stored in is fairly acidic, 3.6. It's actually pretty acidic. Okay, now I'm going to hook this up to my calcium reactor. Okay, I got it hooked up. Funny, I hadn't used this thing yet, and I was almost exactly at 6.5. So I guess it means I didn't really need it, right? No. I'll let it sit for a while and see how it works. Monitor it for the next while. And I'll let you guys know. I'll eventually move this behind so that it looks nicer. But yeah. Well, that's the Weipro pH controller. I'm not exactly sure how to pronounce that yet even. But a few things I noticed. The Amazon listing lists at 0.01% accuracy. I'm not, probably a translation problem there. But it generally keeps things within 0.1 of a pH. So I have mine set to 6.5, goes as high as 6.6, down to 6.4, which is okay, especially since that's not as hard on the relay, and it shouldn't really matter for the calcium reactor, right? I wouldn't exactly want that on a fish tank, regulating the CO2 going in a fish tank. I'd much prefer a thyristor-based solution, just so that you can be fine-tuning it a lot. So right now it only switches once every half hour or so. It takes a long time for it to actually switch, going between those that 0.2 gap. That's quite a bit. Well, it should be okay. If you want me to look at anything else, I do have a couple other videos planned, just general stuff I've ordered that don't really find any good information on off the internet. So stay tuned, subscribe, comment if you want to make a suggestion of what else you want me to test with this, or if you want me to do a teardown of it, maybe look at a modification to make it use thyristor instead. Maybe even see if we can get that accuracy just a bit closer. Odds are it's just controlled by it's either controlled by software or hardware. And if it's software, it's unlikely I'm going to be able to reprogram this thing without a lot of research. If it's controlled just by like a pot inside there or a fixed resistor value, then there's very much a possibility. We'll have to see. But yeah, let me know. Catch you next time.